So another question asked is, what is entropy? Okay, entropy. So what is S? In the class, I listed S equals to K, which is both stem constant. So it's a small number. Let's put a small number. Okay, and Ln, there's something called here, omega. Okay, this omega is number of microstates. Okay, basically your question is, I did mention S is something macro, microstates. Okay, so treat when you say micro as something large. Okay, like temperature, volume. Okay, it's something you can steal them. It's like a see in your life. Treat this one as something large. Okay, when I say microstates, okay, it's in very tiny. Okay, in the level of atoms. Okay, atom level. Okay, microstates. I was showing I can show to you later. It's on my iPad. It's like a model. Later we'll also show to the class as well. It's showing what's the possibility to see where an electron could show when we were talking about particles. We'll talk about this. So that's animation. Basically, you will see if there are only one electron, but you will see that electrons show up here, all over the place. And later, just by seeing where is the possible place that you can see that electron, you will see a circle. So that was something we are talking about in that level. But all of them, it's not visible with your eyes. It's in the atom level. Let's say, if you still remember Na, that's Avogadro's number. Even that, and that's not even just like this is one atom. 1 moles of whatever stuff will have huge amount. So all of the microstates will be in this level. Okay. The real microstates include, let's just use 1 electron. Okay, there's 1 electron. Real microstates include, well, what's the speed of this electron? Does it want to move this way? What's the direction of that? What's the momentum of that electron? But these are the possibility of microstates, which that's why we say number of microstates. It's just a lot of, let's say, in the very tiny level, what's the possibility of these electrons could do? That's just treat them so far, and S, which you can imagine if it's in our daily life. Let's say even just 1 piece of whatever wood or something will have huge amounts of atoms, which means this omega will be usually a huge number. That's the normal case. Okay, that's why we said, because all of the electrons can have their own directions. You have Avogadro's numbers of electrons, atoms. They're all moving in their own direction, whatever. That's just caused the disorder. There are so many possibilities. They're all pointing at different directions. They're all moving at different speed, right? Okay, that's why this will be a huge number. So this will be a large number, usually. Okay, large number, and that's how we tie something micro to macro. Just this is the this is when we tie a concept that's in tiny scale to the normal scale. That's the delta S. It's not quite right to use S this order to describe S, because basically the increase of this order means you have increase of number of microstates. That's the correct way. But concept-wisely, you can still use, if you're tidying a room, to say that's S. That's okay. Which means the more clean your room is, the smaller the S. Not the most accurate way, but just try to use that. Are we good?